Welcome to a minor series video. In this video, we are going to discuss the diagram that is used when you are proving your sine rule, your cosine rule, and your area rule. So there are two diagrams in actual fact. You can either have an acute angled triangle or you can have an obtuse angled triangle. When you are given an acute angle triangle, you are going to be presented with your triangle in a Cartesian plane, and normally it will be labeled with coordinates A, B, and C, or whichever coordinate. Now, what is key is that when you are given this, you need to label your your points or your vertices of your triangle. So A is at the origin, so it will have coordinates 0 and 0. So your x is 0 and your y is also 0. Now you have your B. What is important is that you remember this. In the end, I will try and explain how we get our x coordinate to be c cos A and how we get our y to be c sine A. And then you have your coordinate C, which will have the coordinate B and 0. Now, because this is a triangle, the side which is opposite to the point or the vertex which is A will be small letter A, and then the side opposite to B will be small letter B, as well as the side that is opposite to C will be small letter C. Another key addition to the diagram, now this diagram that I'm talking about will be given in the question paper at the very end. So these are the additions that you need to make in order to complete your proof. So one of the key things is that you have to indicate your vertical perpendicular height. So you indicate using your lead pencil, and it should be a dotted line. Without this line, your proof will collapse. So it's very important that you indicate this in your diagram. Of course, it is perpendicular to the x-axis. Now you can label your line, your dotted line H, which stands for vertical height or perpendicular height, and then you can label the end of that line as point D. Now let me explain how we get the coordinates of B. So if you focus on triangle ABD rather, which is a right angle triangle, that means we can use our trig definitions. If we're in a Cartesian plane, we say that sine is y over r. So we'll say sine of angle A will be y over r. Now our r in this case will be C, which is our hypotenuse, the side which is opposite to the right angle. And then we multiply by C on both sides, and what we get is y equal to C sine A, and that is how we get our y coordinates for B. Likewise, focusing on triangle ABD, we can say that cos A is equal to x over r, and again our r is C. We multiply by C on both sides, and we get that x is equal to C cos A. If you are not given your diagram, your triangle, as an acute angle triangle, it will be an obtuse angled triangle. But what is nice about these two triangles is that you actually use exactly the same procedures, irrespective of what type of triangle you are given. So you'll have your Cartesian plane, and then you'll have your obtuse angle triangle. You label your vertices of your triangle A, B, and C. And then you label your sides, small letter A, B, and C. And then you draw your vertical height. Now this is drawn from B as it was done in the acute angle triangle. The only difference here is that now this is an external perpendicular height. So it's not inside the triangle, but it is outside. Of course, it is at right angles with the x-axis. So everything that we did, labeling the triangle and drawing a vertical height, is exactly the same. And even if we were trying to see how we get the coordinates for B, it will still be the same procedure. So just like I explained previously, that is exactly how you get your coordinates of B.